Hi, here we are for another video. As Monday, yesterday, it was the International Women's Day, so the videos of this week will be dedicated to that day. So Monday, the video was in Arabic, today in English, tomorrow in French, Thursday in Spanish, and finally Friday in Portuguese. So in this video, I will explain why the International Women's Day is so important. And then I will speak about the work of a very important astrophysicist named Vera Rubin, and she was essential to prove the existence in a solid way, the existence of what we know nowadays as dark matter. Okay, so that's what will be about this video. So please let me just put the slide and then we start. Okay. Okay, here we are. So as I said before, the video of today is dedicated to the International Women's Day of this year, 2021. My name, as you know, is Mariam.Cosmology. If you have any doubt, you can always write to me to that email, mariam.bukhmadi@gmail.com. And you can follow me on the social media at YouTube, Facebook, Instagram, Twitter, and TikTok as Mariam.Cosmology. Okay, here we go. So why is the International Women's Day so important? So it is an important day for the movement in favor of women's rights, okay? So the women, we didn't get usually in many countries the same rights as the men, okay? And sometimes, if not many times, the life of men are much easier than those of women. Now, where does this day come from? So it was mainly celebrated, as I wrote there, by the socialist movement and by some communist countries, China, the former URSS, and so forth. And by the end of the 60s, more precisely 1967, it was adopted by the feminist movement. So there was a day in which the feminist movement, okay, they recognized, or they, yeah, let's say recognized, well, their fight for the women's rights, okay? As I'm Spanish, well, I would like to remember to everybody when was the first Women's Day March. Well, it took place in Madrid before the Civil War in 1936, and it was led by Dolores Ibarruri, La Pasionaria, okay? So already a long, long time ago. Of course, with the Civil War, then Franco afterward, as you can imagine, there was no longer the International Women's Day, and only years after that day is recovered back in Spain. Now, this year, the United Nations, each year they give a theme, okay, for the International Women's Day. And this year, as you can imagine, is related to COVID-19. So the theme for the UN for this year, for the International Women's Day, is Women in Leadership, Achieving an Equal Future in COVID-19 World. Why? Because at the end, women are those that take care of the kids, that take care of the kitchen, that take care of the family, that take care of everything and more, okay? So it's very important to achieve that equality, and as soon as possible, okay? And now, what is the relation between the International Women's Day and the outreach program that I'm carrying, Cosmology and Gravitation, with these short videos, okay? So essentially, the link here is to highlight the work of a very important astrophysicist known as Vera Rubin. And I choose her because she had a tough time, relatively tough time in science, as we will see on the next slides, okay? And why is it so important? I will explain it in a moment. So it's related to this picture over here. So she was the first one to give solid observational proof to the existence of dark matter, okay? which correspond, as I will mention briefly, roughly to a bit more than 80% of the total matter of the universe, okay? Just 14-15% is made of baryonic matter that can be described through the standard model of particle, okay? So who was Vera Rubin? She was an American, and she was a brilliant astrophysicist. She was born in 1928, and she passed away, unfortunately, in 2016. And we can see her over here on this picture. Well, as I said and I mentioned before, the International Women's Day is very important to remind our rights as women. We have the same right as the men. So Vera Rubin was not allowed to enroll in a graduate program in astronomy, and where? It was in Princeton. And why? Essentially because she was a woman, because of her gender, okay? So these kinds of things, although in this case it happened back in the 50s of last century, cannot take place again, nowhere in the world. She got her PhD from Georgetown University in Washington, and I highlighted there that she was already a mother by then when she got her PhD. This means that she had to work a lot on her PhD, but also as a mother, because she had to take care of her kids at home, okay? And I also highlighted this she's an example to us, so it's possible to combine both things, to have kids and at the same time to carry an excellent PhD work. And what did she do during her work? So essentially she studied galaxies, and she discovered that galaxies clumped together, okay? Somehow some of the galaxies went one next to the other, okay? So that was a revolutionary idea, and it was pursued by other only 20 years later. Why? Probably because she was a woman. They didn't take much care about what she was saying or what she discovered. Now, why is she so important in cosmology and in astrophysics in general? Well, because she provided a solid basis of observation that showed the existence of dark matter. Said in other words, she discovered that most of the matter in the universe is dark. What does it mean that it's dark? So this essentially means that it doesn't interact electromagnetically, which means essentially at the end that can only be detected through its effects on its gravitational effect, okay? So roughly 50% of matter is baryonic, which means essentially that it can be explained through the standard model of particle, and the rest is dark. It only interacts gravitationally. And how did she discover this? Well, essentially through the rotation curves of galaxies. So as I said before, her studies were based on analyzing galaxies. And on these rotation curves, which describe essentially the movement of the different components of the galaxy around its center, what she noticed was that the velocity of the objects that are rotating around the centers of the galaxy, their velocity, increased, almost reach a plateau, which means constant, as we move further from the center of the galaxy. And that was puzzling. Why? Because Newtonian gravity, as well as GR, didn't predict these effects. Let's go to Newtonian mechanics that we explained already on the previous videos in January, if I remember properly, and also in the video of, the video of February, not January. So Newtonian mechanics, what implies that the square of the velocity of rotation of the bodies inside of a galaxy or inside of, for example, the solar system. So what happens is that when we have a massive body that is rotating around another massive body, so the further is that the body rotates in respect to the one at the center, the slower it rotates. And also the heavier is the body at the center, the faster the body that is rotates, the faster is the velocity of rotation of the body that rotates respect to what is at the center, okay? So that's why what they were expecting is the curve here below, that the further you are, or if you are on the outskirts of the galaxy, you expect the velocity of rotation to be smaller than the velocity when you approach the center of the galaxy. But what she observed was that the velocity increased, and this didn't make any sense from what I said, and I highlighted that in red. So essentially, the square of the velocity of rotation is proportional to the mass that one expects it's at the center, okay? And inversely proportional to the distance of the rotating object to the center. So the further you go, if the mass is located and is constant at the center, so the velocity should decrease. Now, if it doesn't decrease, means that there is, because you are further from the center, means that there is more matter, okay? And because that's matter, we don't see it through electromagnetic interaction. This means that this matter is dark, in the sense that it interacts only gravitationally. That matter is invisible, and that's why it was called dark matter. Or it's named dark matter. It's invisible in the sense it does not interact electromagnetically. Okay, so this was a key point and a crucial point for the discovery of dark matter done by Vera Rubin. Okay. So essentially, we expect that dark matter forms some kind of halos at the outskirts of the galaxy and subhalos as well. And that mass is what makes the velocity of rotation of the curve to grow or to reach a kind of plateau as we move away from the center of the galaxy. Otherwise, it's impossible to get this kind of measurement, okay? Or to explain, let's say, better said, to explain this kind of measurement. So nowadays, so this figure essentially described the some simulation of dark matter. So one can see that dark matter forms some kind of halos or filaments, okay, here and here as well, okay? And it's that amount of dark matter that can explain the rotation curve. There are many other observations that support dark matter, but we'll come to that in other videos. So I would like to thank Vera Rubin for being an example for all the scientist women, in particular the cosmologists and the astrophysicists. So thank you very much, Vera Rubin. And of course, I wish everybody a very happy International Women's Day. Okay, and that's all from my side, and see you on the next video. So if you like it, please remember to put a like. Okay, thank you.